Thank you. So let's get started. To start off, I'd like to do a little thought experiment. Is the font size okay? Good, because I can't change it. So here I have a render function, and I just want you to imagine for a minute what this might look like, what it might render. So you can see it's got a layout, and it's got an application monitor, is the title, and then some tabs, and then there's like a user summary, which could be a card or something. And you might be thinking that this would output something like this, right, where you've got the title along the top, and the tabs, and then a card showing the name. And it's a reasonable assumption, but it's completely wrong. Because what it actually outputs here is a terminal application where you've got the title along the top, some tabs, and then a card along the bottom. That's real code that does work. I'll come back to that in a little while. So the first thing I need to talk about is why build a terminal library. There are a few existing options. So there's io.ANSI, which is built into the Elixir standard library. It's really good if you just want to like format some text. It's a great option. It's used by mixed tasks, like when it creates files and things, or in XUnit when you run your test and it does a colorized diff. That's handled by io.ANSI. The most popular library I could find in this space is called Bunt. And I suspect the reason it's the most popular is because it's the default used by Credo, which is a very popular like linting and tool for finding code smells. And it's got a very similar API to io.ANSI, and it's worth checking out as well. And then there's Ratatouille, which is a more sort of full stack tool for building terminal UIs. It's hard to spell, which is its main downside. But one of the issues I had with Ratatouille was like not really to do with the library itself. It's the fact that it uses a NIF. And the NIF it uses is for Termbox, which is a C library that's no longer maintained, that has a build tool that only supports Python 2. So when I wanted to use Ratatouille, I first had to fork Termbox and update the build tool to use Python 3. I then had to fork the NIF bindings for Termbox and update them. And then I had to fork Ratatouille to point it to my new bindings and get it working. So it was kind of a pain. But again, not Ratatouille itself, but the bindings. So then there's Element TUI, which is easy to spell. And it's using Termbox 2, which is like a sort of successor to Termbox. It's nice, it's written in one single C header file, so it's easier to compile and easier to get going. So that's another option there. And then there's OWL, which is a cool library. It's like it does things like you can do state. I'll get there. So you can draw like progress bars, you can draw like status indicators, boxes with borders and things. But its main use case is for drawing ASCII owls. So the goal, when I want to write a library, the main goal is I wanted it to be dependency free. And specifically, I didn't want any external NIFs. And I've said external NIFs here because the beam ships with like lots of NIFs. And I kind of consider them safe to use because every install of the beam will have them available. So that's fine. It needs to handle input as well as output. So some of the libraries I showed on the previous slide were focused on output. But I also want to handle like key presses and things like that. And also alt screen support. So if you are using your terminal and you've been doing some stuff and then you open like Top or Vim or something like that, and it takes over the whole screen, and then when you close it, your output's still there in the buffer. That's using the alt screen. So I need to support that. But before we go there, like we need to look back a little bit. Like what even is a terminal? So in the 1930s, we had the teleprinter or the teletype. Which is like basically two typewriters and like connected on a circuit. And when you type on one, it would like output on the other. So this is the Creed Model 7. And the person in this picture is doing like the 1930s equivalent of like using their laptop in bed. Like that wrist posture doesn't look great. But we moved on. So we had paper-based computer terminals like the Teletype 33 here. So if you think in the 60s, like a computer was big, right? It was like the size of a room. And they didn't really have interfaces into them. So what they would do is hook up one or more of these terminals. And you'd like type your computation here and it would go and the computer would run it. And then the result would be printed on paper. Which is why in like modern terminal emulators, they scroll from the bottom, right? Because it's kind of emulating paper. And then we moved on to screen-based computer terminals, like the VT100 here. And it kind of looks like a keyboard and a typewriter, but it works a little bit differently. So, for example, if you unplug your monitor, at the moment. Like it'll just go black, nothing will display. But on the terminal here, it had like limited computation power, but the computer would perform the computation same as the paper-based versions. But if you unplug the lead, you'll still see the output here. And if you type, like nothing will happen because it's not connected. And then when you plug it back in again, you type, you'll see your characters being printed because they have to be acted by the computer and then echoed back to the terminal. Kind of like if you SSH into something on a like slow connection, you type and it takes a little while to display. That's why. And when we talk about terminals today, we're typically talking about like terminal emulators, which emulate something like the VT100. Like there's some that you may have used. So one thing that modern terminals support is ANSI escape sequences. You might know these as like the weird characters you have to type to get some red text. So the way they behave is they start with like a literal escape, like an ASCII 27. So you can use any of these, like \E, octal 33, hex 1b. They all work. And then you have to use like the actual sequence. And these are all come from a spec called ANSI, called ECMA 48. And it's quite a dry read. They all have crazy names like control sequence introducer and select graphic rendition. But in this case, we're focused mainly on CSI, and they're used for things like moving the cursor or colorizing the output or switching to alt screen, things like that. Device control strings. So I did find an interesting device control strings. There's a spec for images called Sixel images. And if you know, I probably don't need to explain the code there. You can probably figure out what it's doing. So the other thing we have is operating system commands. So these are for setting like window parameters and titles and icons and things like that. We also have terminal input sequences. So if you type a non-alphanumeric character, you'll see this input sequence, which looks like an escape sequence. For example, A, B, C, and D are like up, down, left, and right on the keyboard. And they make your terminal look totally broken. I don't know if you've ever done this, but like sometimes my shell will get in a state and like I scroll the mouse wheel and just outputs like garbage. And you're like, thanks terminal, that is exactly what I meant when I scrolled my mouse wheel. And that's why that happens, you're seeing the terminal input sequences. So this library, no nifs, no buts, no coconuts. I wanted it to have no nif binding, so how did I do that? In OTP 26, something new was introduced called primtty, which I guess stands for like primitive teletype. And it's used by default, so if you are in your Erlang shell or IEX and you press Control-C and you see that menu that says abort and continue, whatever, and you never actually mean to open it. But if you go in there, that's powered by primtty. It supports handling input with raw mode as well, so normally when you're on your terminal, there's like a little buffer you can type in, you press backspace and it deletes and it'll echo all your characters, and it's called cooked mode. So this is like raw mode where you want to handle the inputs yourself. And then it's got this really nice message-based API for handling keyboard inputs and like Unix signals, so you can just handle it with receive or handle info if you're in a gen server. So it's pretty familiar there. So the library I've built is called Termite. And it's an adapter-based terminal library, so you can like switch out the adapter. And the main reason I made it adapter-based is because primtty is like module.false in the beam, which means it's not like, you know, it could change without warning. Or the OTP team could just like rug pull me entirely and delete it. So I wanted like a way to, if that did happen, you could like build a termbox binding or one of the many thousands of Rust terminal libraries, and it would just work. And then I want this simple declarative output API as well. So here's an example of what it looks like. So you start a terminal, and then you can like build up a styled string, and you can write it out to the terminal, and that will output this beautiful hello world. So one of the modules, there's not like that many modules in Termite, but one of the modules is termite.style. So this is how you build a styled string. So it's designed to, you can kind of guess what's going on here. It's chainable, so in this case it's going to be bold. Using the ANSI 256 color space, set the foreground background color. There's an escape code for reverse, which like swaps the foreground background colors. Under like blink, like did you know your terminal could do blinking text? And then you can render to a string, and then you'll see, it's quite small, but you can see the blinking text and like this wild escape code to generate it. So like as an aside, like what is the deal with terminal colors, right? It just looks like this random assortment of colors. And if you're ending like me and you see like an integer, you just increment it to see what happens. And you're like, okay, I got this. Okay, it's blue, it's more blue, it's more blue, it's green. Like, what's happened? So I got all these images from a gist. It was created, well, the gist wasn't created by this guy, AltGiro, but the actual infographic buried inside it is, and it's like a really good resource for this. So the way that terminal colors work, you've got your first 8 colors, and these are escape sequences for them. So there's kind of some logic here, right? They differ by 10 for foreground and background. And these are the actual colors, although there's no spec for what these colors actually should be. This is the names for them. And it goes from 30 through 37, and if you read the spec, it says that 38 is reserved for something else, which we'll come on to. And then at some point, they must have went like 8 colors, like, come on, we need more colors. And they went, okay, what if you could have the same colors but slightly brighter? And they went, yes, okay. So these are the bright variants, and they differ by 10 as well. Kind of similar logic there. And then at the end, you've got these like 24 shades of gray. So the escape sequence for those is using the 38 that I mentioned. So it's got like a sub mode. In this case, it's sub mode 5, which is for 256 color. There's also sub mode 2, which is for like RGB values. But the interesting colors for me are like the middle 224 colors. And if you restructure them into groups of 6, you can kind of see some logic here where like it's going more blue from left to right and more green from top to bottom. And then like in each block of 6 lines, it's getting more red. So if you imagine that as like a cube, then you'll see like, okay, it makes sense. It's going blue across the top, green down the bottom, and then red through the layers. And like you can calculate the color now. So like hex colors go from like 0 through to FF. And these are kind of similar. They go 0 through 5. And then there's like a sum you can do where you multiply them. And I've actually got really good at this through this resource. Like I can do pretty much any color. Like if you just shout out a color, I'll be able to tell you what the number is. Yellow, that's what I heard. So yellow is all the way green and all the way red, and the sum for that is there. So you do 5 times 36 plus 5 times 6, and you get 226, because you have to offset by 16 for the normal and bright variants. And there you go, it's yellow. So another module that's available is the Termite screen module. So this is like slightly different to the Termite style, which is for building up styled strings. This is for like escape sequences that output directly to the terminal. So in this example, it's like clearing the screen, it's writing the string hello world to the normal screen, switching out to the alt screen, and then writing to the alt screen, and then exiting again. And those all just, they write as soon as they're called. And then I mentioned handling inputs, so there's like a message-based, so you can use receive or handle info. We have this wrapper around receive, which can handle the refs. So in this case, you call pull, and then if it's a key press, like up, down, left, or right, you'll get the data coming in with that escape, like that terminal input sequence, and we just move the cursor around using these functions available. Q is like just press Q, and we just exit. And then on the timeout, like every second, it's just going to write a dot to the screen, and all of these loop. And then you can also get Unix signals, so think like sigterm, sigkill. In this case, we're getting like Sigwinch, which is stands for window change, and that gets called when you resize the terminal. So in this case, the terminal window is resized, and we tell Termite about it, and Termite will recalculate the dimensions, and then it will re-render. Fun aside about the winch signal, when I was like searching to see what it is, I came across a lot of resources about the Apache 2 web server, and it uses like SigUser1 for like graceful restart and SigUser 2. And I guess at some point they ran out of available signals. So for the Apache 2 web server, if you are running it in the foreground, they use the Sigwinch signal for graceful shutdown. So if you're running Apache in the foreground and you resize your terminal window, it shuts down. And yeah, that's the main thing you find if you search for Sigwinch. Okay, so I got time for a demo here. So the first thing I want to show is the colors demo. This is like the hello world to make sure your color's working. And you'll notice my basic ANSI colors are absolutely nothing like the one I mentioned. Like there was no mention of purple. How have I got purple in there? In fact, they're not even brighter. They're just like different. And that's like down to how your terminal palette works. Like it just depends on what you're doing there. But the extended ANSI colors are the same, right? There's more interesting demos. So there's one here, which is like the terminal window, and I can move the cursor around. But the hang on, I can make this bigger. There we go. But the interesting thing about this one is like it's responding to the window change event. So if I resize the window, you see that it redraws the panel all the way around the border and reports the size, and it changes. And then like it supports like emojis. So if I run this one here, you'll see that there's a little termite just at the bottom there, right there, eating his way across. It's not a cockroach, and he's eating his eating his way across those. But I'm sure the actual good demo here is this one here. There we go. Look at that. So that is Snake running in the terminal, right? I'm not stopping. No, that was the whole reason I built this, is because I wanted to build Snake. Now, I know what you're thinking. I actually think I heard someone whisper it at the front there. And the answer is yes. This does work in Livebook. So, like if I, right? So I wrote a Kino adapter, right? Because it's adapter-based, I can write my own adapters. And I wrote a Kino adapter, and it's built on top of Xterm.js, which is like a JavaScript terminal emulator. And there's this output function I added, which will output it. It's like a Kino cell. And here is the example I mentioned, where like it writes some text to the buffer, to the normal screen, and then switches to the alt screen. Wait. And then switches back. Yes. And then also, I have the Sigwinch demo here. And the interesting thing about this one is that the resize isn't really that easy to calculate compared to like just doing it in the terminal, right? So what's happening here is like the Xterm.js has a resize event that you can listen to, like a JavaScript event. And when that event triggers, I tell the Kino adapter there's been a resize event, and the Kino adapter goes back to Xterm.js and says, what are your dimensions? And then they get reported back up over live view. And then Termite says, okay, I know your dimensions now, I'll re-render, and then writes the content down the WebSocket, and then Xterm.js renders it. And obviously, Snake works in, oh, I pressed it twice. Snake works, no it doesn't. It does, you just have to run it 5 or 6, there we go, see I told you. So Snake works in the browser, in the terminal, in the browser, in Livebook, and that's important. Right, so I want to go back to the slide at the start, right, because I completely lied, because this isn't a live view. It's using something called Breeze, which is, it's kind of like a live view inspired API, and it's a way for building like terminal UIs that I'm working on. It's quite experimental, but you like can use breeze.view, and it's got a very live view style API, so it's got a mount callback. And in there you can assign, and that's where the user gets assigned. And then like underneath there's the render function that I forgot to highlight, but it's the same one I showed at the start. So that is rendering Heeks in the terminal. And it's built on top of another library called Backbreeze, which is kind of like Tailwind. And you can pass like a string of classes, and it will rewrite them as structs that then get rendered by Termite. So you can do things like grids or like boxes with borders, things like that, offsets for like scrolling. And then Breeze is built on top of that, so I think I might have some more examples of Backbreeze. So there's some like, for example, it's rendering a grid here, and what Backbreeze has got to render that is it's got like a tree of structs, and it'll say like, okay, this one's rendered as a grid. In fact, it's a nested grid, right? The one in the middle is like a vertical grid, and the other one's got three columns. And yeah, so the idea is that you'll use Breeze on top of this, and it'll support, it supports handle info and handle event, and it rewrites the terminal input sequences to like regular, like so you get like handle info, handle event with arrow up, and that's how you know the app arrow's been pressed, which is easier to remember than like / left brace uppercase A, in my opinion. So. Yeah, that's kind of what I've got. Thanks for listening. Those are the links to the libraries and the infographic that I mentioned. So yeah, thank you.